Welcome to 6.5. This section, which covers solving polynomial equations, is going to have two videos. First video is going to be some review and some new material. We're going to be factoring. And then the second video, we're going to use that factoring to solve. So let's jump right in. As you can see at the top, it says, like quadratics, some cubic polynomials can be factored with special rules. So you're learning one new special rule today, and it's called the sum and difference of cubes. You can see in the box, on the left side, we have the factoring technique, and on the right side is the general case. So we have a sum of cubes and a difference of cubes, and this is how they both factor. Now, I understand we look at this and it's a little complicated. That's okay. I have an acronym that I'm going to show you to help you through this one. Okay, one thing to notice is you can factor both a sum and a difference of cubes. When it's a square, we can factor a difference of squares, like x squared minus 4. We cannot factor, though, a sum of squares, like x squared plus 4. But if it's cubes, you can factor both. So I think it's best if we just jump into some examples, and it'll show us how these cases work. In example A, it says factor if the polynomial cannot be factored right prime. I will not give you any that cannot be factored. All of the ones that I give you will be factorable. So let's start with example A. Anytime you're factoring, very first step, as we've talked about many times before, is to look for a GCF. So do I have any GCF, or do I have a GCF I can factor out of 8x cubed and 27? All I have is a 1. That's not helpful, so there's no GCF in this case. Now, we have to ask ourselves, is this a sum or difference of cubes? Is 8x cubed a cube? Is 27 a cube? Yes, it is. 8x cubed is really 2x to the third. 27 is 3 to the third. So this does factor. It's going to have two different factors. The first one comes from these numbers. So we have 2x and we have 3. This second factor, this is the harder one. Here's what you're going to do. That 2x cubed, I'm going to write it out 3 times. So 2x, 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 and then I have 3, 3, 3. You're going to circle every pair of 2, or every 2. So I'm going to circle 2, I'm going to circle 2, and I'm going to circle 2, and you're going to multiply. So 2x times 2x gives me 4x squared. 2x times 3 gives me 6x. 3 times 3 is 9. Last thing we have to do is figure out our signs. Here's the acronym to remember. SOAP. S-O-A-P. S stands for same. So if there's a positive here, I want the same sign. O stands for opposite. So instead of positive, we're going to have a negative. AP stands for always positive. So let's write that same, opposite, always positive. Okay, I know that's confusing. We're going to do another example. Let's look at B. 5y to the fourth minus 320y. Is there a GCF? Yes, there's a GCF. So make sure you pull that GCF out. I can take out a 5y. I then have y to the third minus 64. Is this a cube? Yes, it is. This is y to the third minus 4 to the third. So let's write out our factors. Remember, the first factor, I'm just taking these two, so y and 4. Second factor, this is where I need to write out. So I'll do y, 4, 4, 4. So ignore that sign in the middle, it doesn't matter, or doesn't matter yet. Circle every 2. Y times y is y squared. 4 times y is 4y. 4 times 4 is 16. So then for our signs, remember, same, opposite, always positive. If I have a negative here, I have a negative here. Same, opposite, always positive. Please do not forget we took out a GCF. That GCF needs to come down. So this is our fully factored form. Now, I think some of us are probably asking, what does this mean? If I were to multiply this all together, I would get back to where I started. Same thing in A. If I were to multiply all of this together, I would get back to where I started. Why are we doing this? We want to solve polynomial equations eventually. So that's what we're getting towards. This is the first step towards solving polynomial equations. Let's look at part C. Part C, is there a GCF? No. Then we have to ask ourselves, are these perfect cubes? Yes, they are. 64x cubed is really 4x cubed. 125y cubed is 5y cubed. Oh, cubed is in the wrong spot, sorry. Now you should be ready to factor. Take a minute, pause the video, and try this one on your own, please. When you are ready, come back and we will move on. Okay, let's move to the next page. Now that we've learned our new factoring technique, I want to review factoring in general. So this table should help you factor in general. Remember, first step is always, no matter what, you're looking for a GCF. First step, always look for a GCF. Then you're asking yourself, how many terms do I have? 2, 3, or 4? So once I've taken out my GCF, if I have 2 terms, there's 3 options. Difference of squares, sum, and difference of cubes. Remember, a sum of squares does not factor. So if we have a squared plus b squared, doesn't factor. Anytime it's squares, only factors if we're subtracting. If it's cubes, both will factor. If we have 3 terms, we're going to split the middle. Box method, I don't use, some of you may use. And then anytime we have 4 terms, we're factoring by grouping. That just means you're splitting the line down the middle. Factoring by grouping, you're just splitting the line down the middle. Okay, so let's jump in. Example 2, we have 2 terms. Don't look at the list just yet. We got to ask ourselves, is there a GCF? Is there anything I can factor out of both of those terms? Yes. Out of both 15 and 10, I could take a 5. I have a squared and a, so I'm going to factor out an a. B and b, I'm going to factor out a b. Okay, 15, if I take out a 5, I'm left with 3a. 10ab divided by 5ab gives me a 2. This is it. Don't set it equal to 0. There's no equal sign. Don't set it equal to 0. Now, if you wanted to check your answer, what you could do, multiply this back out. So I would get 15a squared b minus 10ab, which is what I started with. So I got the right answer. In parentheses, that 3a minus 2 doesn't factor anymore. But do remember that that's something you need to look for. Okay, in B, is there a GCF I can take out? No, just a 1. Then I need to ask myself, what kind of factoring is this? 3 terms is going to be split the middle. Don't forget this 3 out in front. So I'm looking for 2 numbers that multiply to 15 and add to 8. Hopefully we can tell that that's 3 and 5. So this middle term is going to split to be 3 and 5. We need to be careful though. It's a t squared, so this will be 3t squared plus 5t squared. Remember from before that order doesn't matter. Bring down the first term, bring down the last term. Now we're ready to take out our GCF. GCF on the left side is 3t squared, and I'm left with 3t squared plus 1. Don't forget the 1. That's the most common mistake. Right side, I can take out a 5, and I'm left with t squared plus 1. Now at this point, my parentheses should match. Mine don't. Uh-oh. Either I split wrong or I factored wrong. Now, taking a look back, I notice I shouldn't have a 3 here because I already factored that 3 out. Now my parentheses match, which is good. My first factor is that t squared plus 1. Second factor is what's outside. Now, we don't necessarily know that we're done yet. We need to ask ourselves, do either of these factor more? No. T squared plus 1 is an addition of squares, or sum of squares. That doesn't factor, though. 3t squared plus 5 also does not factor. So we are finished. If you wanted to check your answer, you could multiply those two binomials out, and you should end up back where you started. Looking at C. Do I have a GCF? Be careful here. Is there something I can take out of all 4 terms? No. Now I have 4 terms, so I'm factoring by grouping. Like I said, factoring by grouping, you're just splitting a line down the middle. So on the left side, I'm going to factor out an x, and I'm left with x minus y. The right side, I'm factoring out a 2, and I'm left with x minus y. My parentheses match, which is good. Now, one thing I want to be careful about here. Right now, with our notation, it looks like everything is being multiplied. And that's not what we mean. There needs to be an addition sign here. So that's something that we really commonly forget. And it just is poor notation. So last step, first factor is the stuff that's repeated. Second factor is what's on the outside. You can write those in the reverse order, that's fine too. Okay, and that one's done. Last problem is D. I want to do D with you. This is 2 terms. So, based on the table above, we must have squares or cubes. Squares or cubes. X to the 4th is obviously not a cube. X to the 4th is obviously not a cube. Can we write it in terms of a square? In terms of a square. Well, this is really 9x squared squared minus 16 squared. That should help us with our difference of squares. Difference of squares. So I have 9x squared minus 16, 9x squared plus 16. You are not done. You are not done. At least one of those factors. At least one of those factors. So right now, I would like you to finish this problem. You need to finish this problem and turn your notes in. If you want to see a few more examples, these are optional. Please flip to the next page with me. So again, these are some extra optional examples if you want to watch them. Might be a good idea to pause the video and try these before you see me go through them. So you might want to try them before you see me go through them. Let's jump right into E. We're going to start by factoring out the GCF, which is at 2. We're left with r cubed add 64. Now, this is a sum of cubes. R cubed is r, 64 is 4. Don't forget that you're going to have 2 factors. Sometimes people forget the first set of parentheses, which is just the r and the 4. The second set is when we're circling those pairs. So r and r is r squared. I then have 4r and 16. Remember our acronym of SOAP. So we have same, addition, addition, opposite, always positive. Please don't forget to bring that 2 down. Your GCF should always be part of the answer. We don't want to forget about it. Now again, if you want to know if your answer is right, multiply it out, and you should get back to where you started. In F, is there a GCF I can take out? No, nothing more than a 1. So now we move on. We have 3 terms, so we're going to split the middle. Don't forget about that 6. Looking for 2 numbers that multiply to negative 18 and add to 7, number in the middle. So I'm going to use 9 and negative 2. So remember that middle term splits into 9x minus 2x. Those should be equal. So we need to ask ourselves, is 9x minus 2x equal to 7x? Yes, it is. So bring down the 3, bring down the 6x squared. Now we're ready to factor. Left side, the GCF is 3x, and I'm left with 2x plus 3. Right side, I take out a -1, and I'm left with 2x plus 3. Parentheses match. Always make sure that's the case. If they don't match, you did something wrong. So then my factors are 3x minus 1, which is the stuff outside, and the 2x plus 3. Okay, G, last one. Take out your GCF, which is 2. Now we need to ask ourselves, is this a sum or difference of squares or cubes? Yes, it is. R cubed is RRR. 125 is 555. So this one's similar to E. Don't forget the first set of parentheses. So remember I said a lot of times students will forget the first part. First set of parentheses is just the R and the 5. When we start circling, that's when we get to our second set. So R times R is R squared, 5R, 5 times 5 is 25. We have same, opposite, always positive. If you did all that work, please do not forget your GCF. Again, if you wanted to check your answer, you could multiply this out, and you should get back to where you started. Thank you for going through a few extra examples with me. I hope that they were helpful. If you have any questions, write them down, and you can email me, come to office hours, or ask in class. This section is really important. It's the foundation of solving. So we got to make sure that we understand this factoring well. Again, if you have any questions, please ask.